today we're going to look at problems that have negative exponents. When you see a negative exponent, a lot of kids think that means the answer is negative. It's not. It just means you have to flip. So we think of flipping action when we see negative exponents. So again, it's a notation thing. So when I see 4 to the negative 2, I suggest you kind of visualize that 4 is technically over a 1. So I'm simply going to flip that and make it 1 over 4 to the, and now it would be positive 2 because you flipped. So whenever you flip to the opposite side, it changes your exponent to a positive. That's what that means. And then you would simplify. So obviously 4 squared is 16. It's just your answer would be 1 over 16, not 16. A lot of kids think the answer is negative 16, and that's not what it means. So then if you have 4 to the negative 2 already on the bottom, then you simply flip it to the top, and it's just 16 over 1. And then we start making it trickier. So we'll put some fractions and some negatives together, but you just take it one step at a time. So the first thing I would do is I would flip it, make it 1 over 8 to the positive 2/3. Then I would change this to root form. Cubed root of 8 squared. And personally, I probably would just do the cubed root of 8 first and make that 2. Then apply the squared, so final answer is 1 over 4. So that's what we're going to do with these couple ones. We're just going to practice going from that root or that exponent to that root form, and we might have to do some flipping. All right, so this one right here was a square root of 4 to the 5th. 4 to the 5th is kind of hard to do in your head, so it's easier to apply the square root first. Square root of 4 is 2. 2 to the 5th is 32, and that's it. That's done. Letter B, we have a negative exponent, so I recommend flipping first. Just simply put the 9 to the 1/2 on the bottom, but make sure it's positive now. And then change 1/2 into square root, and the square root of 9 is 3. So the answer is 1/3. Letter C, they're trying to catch you off guard. 81 is definitely special for a couple of different reasons, but the 0.75 is also kind of a special decimal. That is the same thing as 3/4. So it's easier to turn that into radical form. So sometimes they try to be tricky and give you decimals. That means we're going to do the 4th root of 81 cubed. And again, I would like to do the 4th root first, and that's just 3. And then 3 cubed is 27. Then we're back to a negative exponent. So again, we're going to flip first, get rid of that negative. We don't like negatives. Then we're going to change 1/2 into square root. And we learned it's not okay to leave a root on the bottom. So we're going to times the top and the bottom by root 2 and get root 2 over 2. And then letter E, again, we need to flip it. We do not like negative 4/3 as an exponent. Then we're going to change this to root form, cubed root of 64 to the 4th. The cubed root of 64 is 4. And if I take that and raise it to the 4th power, I get 256. So at this time, I'd like you to try 3 and 4 on your own. I gave you one positive, one negative exponent just to see if you can handle them. When you're ready, go ahead and unpause the video and we'll see if you got it to work out. All right, you can check and see you should have got 8 for number 3 and 1/4 for number 4. And if you didn't, maybe you can track down why, but here's kind of my thought process when I do the problem. Now, 1 and 2, you haven't seen one like that. 72 is not a special number. That's not anywhere. 64 is a special number, but it's not a special number in 5th root world. It's not in that section that has 5th root on it. So what's the deal? All right, so if you think back, first off, we're going to change it to root form. If you think back to square roots, like if you did the square root of 12, we want to make sure that there were no squares hiding in it, otherwise it could be simplified further. It's the same thing for cubed root. So if I look at my cubed chart, here's my list of perfect cubes. I don't want any of these to be hiding in 72. If they are, we need to get them out. So when I skim down through this list, I skip 1, but I notice 8 is in that list, and 8 does go into 72. So I would break this into cubed root 8 times cubed root 9, and the cubed root of 8 is 2. So that 8 is going to become 8 too. But 9, even though we're used to square rooting 9, it's not a square root, it's a cubed root. 9 is not special in the cubed root world. It's not in this list. It would be a bold number here. It's not in this list. So you can't do it. You just leave it alone. That's how you simplify higher power roots. It's kind of the same thing with this one. So you have the 5th root of 64. If you look at your 5th root box, your special numbers would be 1, 32, 243, and so on. 64 is not in here, but 32 is, and that goes into 64. So we need to get the 32 out of the root. So I separate it into 5th root 32, 5th root 2, cross out the special one, and change it to 2. I can't do the 5th root of 2, so I just leave it alone. So you really need, that's why I make this chart for my students. So when you're dealing with a certain type of root, you want to look for the special numbers in that world, not mix them up with your perfect squares, which is what we're used to seeing. And that's about it.